Okay, my video just quit for some reason. So, back on part B of example 2. We started plugging numbers in. Now we're plugging negative 2 in. Okay, so plugging negative 2 in. Negative 2 plus 3 is 1. What's the square root of 1? 1. And if I take 1 times negative 2?
0.
Negative 2 minus 1? Negative 3. Okay, now, if I plug negative 1 in here, don't plug negative 1 in yet. If I plug negative 1 in here, negative 1 plus 3 is 2. And the square root of 2 does not come out nicely. Okay, so I'm going to skip this guy. I'm going to skip this guy. And I'm going to bump straight to 1. Okay, why do I bump straight to 1? I'm going to bump to this 1. 1 plus 3 is 4. Can you take the square root of 4 really nice? Yes. What's the square root of 4? 2. And then I take 2 times negative 2?
Negative 4.
Negative 4 minus 1?
Negative 5.
Negative 5. Okay, so I'm going to skip those ones that don't come out nicely because I don't want to deal with decimals. Okay, so we're going to plot those 3 points. We're going to plot negative 3 is at negative 1. Negative 2 is at negative 3. And 1 is at negative 5. What the heck does this thing look like? What? Not a very straight line. Okay, we know that his parent function looks like this. He's just upside down. He starts here and he goes this way. Like that. Okay, makes sense? That guy, he does one of those little curvy whoop-de-doo things. Okay, then we have to decide what his domain and range are. Okay, but to do the domain and range, the nice thing to do is find the coordinates of this point. Okay, that point is at the point negative 3 comma 1, right? Okay, that's where he's starting at, negative 3 comma 1. So let's talk about the x's and let's talk about the y's. The x's go left to right. So will this guy go left forever? No. Will he go right forever?
Yeah.
Yes. So he is only x's that are what? X's have to be greater than or equal to negative 3.
The north side of the school is parking for teachers only. Students are not to park on the north side of the school, on the library, on that road. So no students should be parked there tomorrow. Please dismiss the varsity basketball players.
Okay. Goodbye, varsity basketball players. Okay. Do you guys see why he's greater than or equal to negative 3? He is all the x's that are to the right side of negative 3. Okay, to the right. Okay. Now, the range is the y coordinates. The y coordinates are going to have to do with 1, right? And y coordinates go up and down. Will he go up forever?
Nope.
No. Will he go down forever?
Nope.
Yes, slowly, but he will go down forever, okay? So, the y's are going to be what?
Y is less than or equal to negative 1.
Less than or equal to, negative 1. Yeah, I forgot a negative in there. Yeah, it should be negative 3, negative 1. I was missing a negative 1. Okay, y's are less than or equal to negative 1. Good? Does that make sense? Because he's going down. Okay? Good? Happy with that? All right, we've got a couple more examples here. Example 3. Yeah? The backside? Okay, with guitars, pitch is dependent upon the string length and on string tension. Do you know what tension is?
Yeah.
How tight the string is, okay? The tighter you make the string, what happens to the pitch? It goes up really high. If you have a really tight string, it goes up really high. But if you have a really loose string and it's kind of like wobbly, then it will go really low, your guitar, right? You guys know how that works? Okay. The longer the string is, the higher the tension needs to be to produce the same pitch, whatever, okay? This is the relationship between pitch and frequency. And pitch and tension. Frequency and pitch are the same thing. Okay, the frequency or the frequency of the vibration is the same thing as the pitch. Okay, the tension is going to be our T. Okay, so the pitch is going to depend upon the tension, and we adjust the tension likewise, okay? Part A is done for us. I went ahead and gave you the graph because it's kind of ugly decimal numbers when you plug it in. And this is what the graph of the function looks like. So this ugly function right here that has a square root looks like that. Okay, he does indeed look like a square root function, right? He starts here and he goes on forever up that way, right? Okay, so my tension is going from 0 to 10. Is what they have graphed, and then it adjusts my frequency. So like if I have my tension set at 9, it will give me a frequency of 280. Like that's how those intersect with one another. Make sense? Okay, let's go and answer the question. Part B, how much tension, so we're searching for T, how much tension is needed for a pitch to be over 200? What does your tension have to be in order for your pitch to be higher than 200? 200 is my pitch right here. Okay, so if I follow him over, he's touching right here, and you say that your tension has to be more than 5, right? Okay, so how do I write that? T has to be what? Greater than or equal to 5. That's all we have to put, right? Does that make sense? Yeah? Great. Tension has to be greater than 5. Okay, example 4. Find the inverse of x squared. Okay, what undoes an x squared, or what's the inverse of an x squared? Square root. Aha, that's what we're talking about, right? Okay, so let's do the 4 steps. F of x equals x squared. I'm going to rewrite him. What's step number 1 for finding the inverse?
Change x or y to x.
Change f of x to y. Step number 2? We knew what you meant, Luke. Change the x and y. Swap them out. Step number 3, you solve for y. How do I get the y by itself? Take the square root. Okay? Y equals the square root of x. Okay, step number 4, we switch his name back. So we call him f inverse of x equals the square root of x. Okay? All right, I'm going to go back to my pink color, and let's graph the x squared. What does x squared look like when you graph it? It looks like a parabola. So I'm going to start and make my parabola go this way, and I'm going to make him go like this way, and that's what my parabola looks like. Okay? Now, if I graph my inverse function, which is the square root, he starts here and he goes this way, right? Something's wrong here, because he doesn't quite look right. If those two things are inverses of each other, shouldn't they kind of look the same? So Haley says there should be another one here at the bottom, which is actually a positive and a negative square root. Okay, so where did we drop the plus and minus? When we take the square root, we have to include a plus and minus, right? You remember doing that? Remember talking about that? Plus and minus, like the square root of 4 is not 2, it's plus positive 2 and negative 2, okay? So plus and minus, this is the plus part, this is the minus part, right? Okay, now, if they truly are inverses of each other, you should be able to draw a dotted line and tilt your head and make yourself look kind of funny. Are they the same on both sides of that dotted line? Yeah, they are inverses of each other. Make sense? Good, good?
No, because the one on the left.
Well, boy, don't you nitpick my drawing. Okay, there he is. All right? Okay, I'm going to give you your homework assignment, and then we're going to go through a couple of these together just so that we kind of get a feel for it and you know what you're doing, okay? Right here. Okay, there's only one side to this homework page, and we'll do all of them, 1 through 13. Okay, we'll do a couple of them together, so you only have a couple of problems, I guess, to do. Are you holding it?
Yes, I am.
I'm kind of holding it too, actually. So we'll go potty. How about that?
Weird.
Oh, okay, let's do 1, 2, 10. Or no, excuse me, 1, 4, 10 together. Okay? All right, number 1 and number 4 is just saying identify the transformations. So if we start with the square root of x, basically it's asking what is the minus 5 doing?
It's moving it to
Down 5. Done. I'm taking the square root and I'm moving it down 5. Okay, now they get a little bit more complicated when they're doing number 4 because how many things are being done to number 4? How many things am I doing?
2, 4,
3 technically. The negative is a separate piece, right? The minus 2 and then the plus 2. Okay, so there are 1, 2, 3 things happening. Okay, so we'll list them out in order. Okay, now how do you know what order to put them in? Which one goes first? Does it matter the order? It does matter what order you put them in. Okay, here's how I tell my kids which order they go in. If I had a number and I was plugging it in for x, which one of those 3 things would you do? Would you apply the negative, would you subtract the 2, or would you add the 2 to that number first? You would subtract the 2 first, right? Okay, so we're going to subtract the 2. Okay, how does that subtracting 2 move this function? to the right 2. That minus 2 moves him to the right 2, okay? Now, after I've subtracted this 2 and I've applied the square root, would I apply the negative or would I add the 2?
You would add it to.
Apply the negative first, and then you would add the 2. Okay, you would make whatever number is inside of here, you would make that a negative number, and then add the 2 to it, okay? So, what does the negative on the outside do? He's a reflection over the x-axis, because that negative's on the outside, okay? Then, finally, the plus 2. What does the plus 2 do?
You moved it
Up 2. Okay, does that make sense? So those 3 things. Okay, use your cheat sheet. All right, use your transformation sheet. All right, last one, number 10. Instructions for this. Graph each function, state the domain and range. Okay, so we need to graph this guy, and then we're going to do domain, we're going to do range, and then we'll be done. Okay, graph this thing. All right. Whew. How many things are happening to this function? 2. 1, 2. There is a negative 4 and there is a 3. Which one comes first? The negative 4. If I were to plug a number in for x, I would subtract the 4 first before I multiply by 3, right? Okay, so the negative 4 comes first and then the 3. How does the negative 4 move him?
right.
To the right 4, because he's underneath, right? Right 4. What does the 3 do? We're multiplying him by 3.
It's so vertical.
He is vertically stretched by 3. He's being vertically stretched by 3. Okay, so we're taking that normal thing that's usually at 0, 0, and he goes this way, right? He does something like that, and we are moving him to the right 4 units. Okay, so he's now going to start at 4. And instead, he's going to be taller. Okay, now, I had people ask me how much taller. Okay, this point right here is at 0, 0. This point's at 1, 1. This point right here should be at 4. Oh, I'm wrong on my purple. This guy right here should be at 4, 2. Right? Okay? So, if I start here 1, 1, if this is 1 unit tall, he now should be 3 times that tall, right? He should be up here at 3 instead. Okay? This guy right here is 2 units tall. So if I go over 4, like to the 4 mark, he should be 6 units tall. Is that 6? 2, 4, 6? And he should look something like this instead. Let me do a different color. Here, I'll put him in green. This is what my new one should look like. Okay? All right, as long as you're close, as long as you visibly make him taller and move him over 4, that's all I care about. Okay? Now, let's identify your domain and range. This guy where he starts at is the coordinate point what? 4, 0. Okay? Domains are the x's. Okay? Will he go to the right forever? Will he go to the left forever? No, we're only talking about x's that are greater than or equal to 4, because 4 is the x coordinate, right? Okay, the range. Will he go up forever? Will he go down forever? No, we're only talking about y's that are greater than or equal to 0, because that's the y coordinate that we're starting at. Does this make sense? Hey, perfect. Okay, there you go. Do the rest of them for homework, and that is all. We'll see if my recording saves.